sigma I is equal to 1 to n, P of I is always equal to 1. Bernoullis trial, we have probability of x is equal to x is NCX q to the power of n minus x into p to the power of x. At least once, exactly once, at least twice. So like that they will ask. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding the problems in probability. That is a very important theorem, that is Bayes' theorem. Now today in this section I am going to discuss regarding the revision of binomial distribution and the probability distribution problems based on those concepts. Now let us come to the first problem. This is very important type of problem. You may expect this type of question for 3 marks. Just go to the problem. What is the problem given? Let x denote the number of hours you study during a randomly selected school day. The probability that x can take the values has the following form, where k is some unknown constant is given by probability of x is equal to x, 0.1 if x is equal to 0, kx if x is equal to 1 or 2, k into 5 minus x if x is equal to 3 or 4, 0 otherwise. Okay, now find the value of k and what is the probability that you can study at least 2 hours, exactly 2 hours, at the most 2 hours. Here what is required to find the value of k first. Next, the second condition is what is the probability that at least you study 2 hours, at least 2 hours, exactly 2 hours, and the third condition at most 2 hours. So at least 2 hours, at most 2 hours, and exactly 2 hours. That is the given condition. Now let us write the probability distribution first. So based on this, let us write the probability distribution. When x is equal to 0, what is given? P of x is equal to 0. That is, P of x is equal to 0 is 0.1. When x is equal to 1, P of x is equal to 1. So when x is equal to 1, what we will get? K into 1 is equal to k. So this is equal to k. Similarly, when x is equal to 2, P of x is equal to 2 is equal to, put x is equal to 2, that is k into 2 is equal to 2k. And when x is equal to 3, what we will get? P of x is equal to 3 implies, that is, k into 5 minus, put x is equal to 3, 5 minus 3 is equal to 2k. Again, when x is equal to 4, what we will get? K into 5 minus 4, that is equal to 1k, 0 otherwise. Now let us write the probability distribution for this. So therefore the probability distribution is like this. Let us write x and P of x is equal to x. Now when x is equal to 0, 1, 2, 3 and 4, when x is equal to 0, it is 0.1 P of 1. When x is equal to 1, it is k. And when x is equal to 2, it is 2k. And when x is equal to 3, it is 2k again. And when x is equal to 4, it is k. This is the probability distribution. First, find out, write on the probability distribution table and then we can solve easily, right? Now, what is to find first? Find the value of k. So, to find the value of k, let us write down first. We know that sigma I is equal to 1 to n, P of I is always equal to 1, right? Now substitute the value of this. So that is 0.1 plus k plus 2k plus 2k plus k is equal to 1. So this is 2k plus 2k, 4 plus 1, 5 plus 1 is 6k is equal to 1 minus 0.1. Okay, so this is equal to, that is 6k is equal to 1 minus 0.1 is nothing but 0.9, k is equal to 0.9 divided by 6. 0.9 divided by 6. The value of k is equal to 0.15. Therefore, k is equal to 0.15. So, the first answer 0.15 is the value of k. That's it. Okay? Right. Now, let us find out the values. Now, what are the conditions given? What are the condition? First, what is the probability that you study at least 2 hours? At least 2 hours, right? Now, here first condition, probability of at least 2 hours of means probability of x is greater than or equal to 2. That is, probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. That's all. So, first condition is at least 2 hours means probability of x is greater than or equal to 2. Minimum 2 hours must be there. At least 2 hours. So, 2 hours or 3 hours or 4 hours. So, x is equal to 2, x is equal to 3 and x is equal to 4. Substitute the values. What is x is equal to 2? At x is equal to 2, you will study that is equal to 2k. At x is equal to 3 also it is 2k. And at x is equal to 4 it is k. Simplify this. So, this is equal to 4 plus 2 plus 2, 4 plus 1 is 5 times k. 5 into, substitute the value of k. So, 5 into 0.15. So, this is equal to 0.75. That's it. What is the probability? At least you studied at least 2 hours, then the probability is 0.75. Now, second condition. What is the second condition? Second condition is exactly 2 hours. Exactly 2 hours. Second condition. Exactly 2 hours means probability of x is equal to 2. That is nothing but probability of x is equal to 2 means what is probability of x is equal to 2? It is 2k. That is 2 into 0.15, that's equal to 0.3. So, the probability exactly will study 2 hours is 0.3. That's it. Let us come to the third condition. What is the third condition? At most 2 hours. At most 2 hours means probability of x less than or equal to 2. Probability of x is less than or equal to 2 means you can study or may not study x is equal to 0, or you can study 1 hour x is equal to 1 plus x is equal to 2. At most 2 hours means less than or equal to 2 or 0 hour or 1 hour or 2 hours. So, when x is equal to 0, this is nothing but 0.1 that is given from the problem. So, 0.1 if x is equal to 0. When x is equal to 1, it is k, and x is equal to 2, it is 2k, k plus 2k. This is 0.1 plus 3 times k. This is 0.1 plus 3 into k is equal to 0.15. Simplify this. 0.1 plus 0.15 into 3 is 0.45. 0.55. So, the probability of at most 2 hours is 0.55. That's it. This is how we are going to solve. Anyway, this is very important problem. In the examination, they may ask any one, either exactly 2 hours or at most 2 hours or at least 2 hours. So, depending upon the condition, you have to solve this problem, right? Now, let us come to the next problem. Same type, the random variable x of a probability distribution p of x of the following form where k is some number, p of x is equal to k if x is equal to 0, 2k if k is equal to 1, 3k if x is equal to 2 and 0 otherwise. Same type, determine the value of k and the probability of x is less than 2, probability of x is less than or equal to 2 and the probability of x is greater than 2. Now, so straight away they have given when x is equal to 0 it is k, x is equal to 1 it is 2k, and when x is equal to 2 it is 3k. So, since we know that, we know that sigma I is equal to 1 to n, p of I is equal to 1. So, that is k plus 2k plus 3k, this is equal to 1. So, what is this equal to? 3 plus 2, 5 plus 1 is 6k. 6k is equal to 1 or k is equal to 1 by 6. Okay. Here k is equal to 1 by 6. Now let us come to the first condition. So the value of k is equal to 1 by 6. Now let us come to the first condition. Probability of x is less than 2. P of x is less than 2. P of x is less than 2. X is less than 2 means P of x is equal to 0 plus P of x is equal to 1, because the condition is less than 2. If it is less than or equal to means we can take P of x is equal to 2 also, but it is less than 2, therefore P of x is equal to 0 plus P of x is equal to 1. When x is equal to 0, what is the value of P of x? It is k, plus when x is equal to 1, the value of P of x is 2k. So this is equal to 3 times k, 3 into, since we know that k is equal to 1 by 6, so this is 3 to the, therefore probability of x less than 2 is equal to 1 by 2. This is equal to 1 divided by 2. That's it. Okay. Now the second condition. What is the second condition? X is less than or equal to 2. Now let us come to the second condition. Probability of x is less than or equal to 2 means probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2. X is less than or equal to, that is less than or 2 means 0, 1 and 2. Now P of x is equal to 0. Probability of x is equal to 0 is k, plus x is equal to 1 is 2k, plus x is equal to 2 is 3k. So if you add this, 3 plus 2, 5 plus 1 is 6 times k, 6 into, since k is equal to 1 by 6, so this is equal to 1. So probability of x less than or equal to 2 is 1. Okay. What is the third condition? Probability of x is greater than or equal to 2. The condition number 3, probability of x is greater than or equal to 2. Probability of x is greater than or equal to 2 means we have only x here. So therefore this can be written as probability of x is equal to 2. What is the probability of x is equal to 2? It is 3k. 3 into k. This is 3 into, since we know the value of k, k is equal to 1 by 6. So this gets cancelled. This is also equal to 2. So probability of x is greater than or equal to 2 is also equal to 1 by 2. That's it. This is how we are going to solve this probability distribution. Anyway, this type of problems are very, very important. Hope you followed. Okay. Now let us come to the next problem. Now what is the problem given? Same. If a pair coin is tossed 10 times, how many times we are going to toss? 10 times. Find the probability of exactly 6 heads, at least 6 heads, at most 6 heads. This is very important type problem for 5 marks. Now, just if a fair coin is tossed 10 times, find the probability of getting exactly 6 heads, at least 6 heads and at most 6 heads. Now, what is the condition given? So, the repeated toss of a coin is called the Bernoullis trial. This is a Bernoullis trial. Suppose let x denotes the number of heads in an experiment of 10 trials. Suppose if x denotes the number of heads, if x will denote the number of heads in an experiment of 10 trials, since this is a repeated tosses, so repeated toss of a coin, therefore this is a Bernoullis trial. Now let us come to the first concept. When x exactly 6 head means probability of getting x is equal to 6. Before that, let us write down the value of p. What is p here? Here n is equal to 10 and p is equal to 1 by 2. Clearly, x will have the binomial distribution with n is equal to 10 and p is equal to 1 by 2, and q is equal to 1 minus p, that's equal to 1 minus 1 by 2, that is also equal to 1 by 2. So, clearly x has the binomial distribution with n is equal to 10 and p is equal to 1 by 2. Therefore, p of x is equal to x is given by ncx into q to the power of n minus x into p to the power of x. Cx into q to the power of n minus x into p to the power of x. So therefore this can be written as n. What is n? N is equal to 10 Cx. What is q? Q is equal to, the value of q is 1 by 2 to the power of n is 10 minus x into p. P is also equal to 1 by 2 to the power of x. So therefore this can be written as 10Cx. So using law of indices, 1 by 2 to the power of 10 minus x into 1 by 2 to the power of x minus x plus x gets cancelled. This is 1 by 2 to the power of 10. So probability of x is equal to x is 10Cx into 1 by 2 to the power of 10. Now let us come to the condition. Exactly 6 heads, at least 6 eggs, and at most 6 heads. Okay. Now come to the first condition. P of x is equal to 6. What we have? Probability of x is equal to x is given by, that is 10Cx into 1 by 2 to the power of 10. So probability of x is equal to 6 is 10C6 into 1 by 2 to the power of 10. Simplify this 10C6. 10C6 can be written as factorial 10 divided by factorial 6 into 10 minus 6 is 4 factorial. This is 10 into 9 into 8 into 7 into factorial 6 divided by 4 into 3 into 2 into 1 into this factorial 6 gets cancelled. So this is 4 2s are 8 and 3 3s are 9. So that is 10 into 3 is 30 into 7. This is equal to 210. So this is 210 into 1 by 2 to the power of 10. Now if you simplify this, this is 210. If you multiply 2 10 times, 2 into 2 into 2 into 2, this is 1024, 1024. You can divide by 2. If you divide by 2, this is 105 divided by 512. So therefore probability of x is equal to 6, P of x is equal to 6 is 105 divided by 512. So that's it. So in the examination they may ask any one condition like this. Now let us come to the second condition. Second is probability at least 6 heads, means probability of x is greater than or equal to 6. Greater than or equal to 6 means P of x is equal to 6 plus P of x is equal to 7 plus P of x is equal to 8 plus P of x is equal to 9 plus P of x is equal to 10. X is greater than or equal to 6. Greater than or equal to 6 means 6. Greater than 6 means 7, 8, 9 and 10. So what is the value we have? P of x is equal to x is given by P of x is equal to x is equal to 10Cx into 1 by 2 to the power of 10. So the general formula is, what is P of x is equal to x is 10Cx 1 by 2 to the power of 10. Just replace x by 6, 7, 8, 9 and 10. That's all. So P of x is equal to 6 means 10C. What is x? 6 into this 1 by 2 to the power of 10 as it is. Again 10C into x is 7 and this is 1 by 2 to the power of 10 as it is. Again 10C, x is 8, 1 by 2 to the power of 10 plus 10C9, 1 by 2 to the power of 10 plus 10C10, 1 by 2 to the power of 10. Now you can take 1 by 2 to the power of 10 common factor. So what is left over is 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10. Simplify this. So after simplification, the answer we are going to get it is 193 divided by 512. That's it. Find out the value of 10C now, 10C6, 10C7, 10C8, 10C9 and 10C10. Simplify. So in the denominator 2 to the power of 10 and divide it, you will get 193 divided by 512. That's it. Come to the next third condition. At most 6 heads means x is less than or equal to 6. X is less than or equal to 6 means x is equal to 0, probability of x is equal to 1, probability of x is equal to 2, plus probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6. Less than or equal to 6 means 0 to 6. Now substitute the value. Since we know the standard value, p of x is equal to x is what we have? 10cx into 1 by 2 to the power of 10. Here also just replace x by 0 to 6. So this is 10 c naught 1 by 2 to the power of 10 plus 10 c1 1 by 2 to the power of 10 plus 10 c2 1 by 2 to the power of 10 plus 10 c3 1 by 2 to the power of 10 plus 10 c4 1 by 2 to the power of 10 plus 10 c5 1 by 2 to the power of 10. The last one is 10 c6 1 by 2 to the power of 10. So here also you can take the common factor 1 by 2 to the power of 10 and simplify the remaining 10 c naught plus 10 c1 plus etc. The last term is 10 c6. Now if you simplify this, the answer you are going to get in the denominator 2 to the power of 10, this is 1024. In the numerator, if you simplify, you will get 848. 848 divided by 1024. If you want, you can divide by 16. If you divide by 16, this can known as 53 divided by 64. That's it. This is the probability of x is less than or equal to 6. Okay, that's it. Now let us come to the next problem. Similar type problem. A die is thrown 6 times. If getting an odd number is a success, what is the probability of 5 success, at least 5 success, at most 5 success? So, if a die is thrown 6 times, number of times we are going to throw is 6 times, n is equal to 6. If getting an odd number, if you get an odd number means it's a success. So, if such is the case, how many 5 success? At least 5 success and at most 5 success is to be determined here. Let P be the probability of success, that means getting an odd number. This is a Bernoullis trial with n is equal to 6. With n is equal to 6. What is given? A die is thrown 6 times. So, yes, die is thrown 6 times. Getting an odd number is a success. What is the probability of 5 success? At least 5 success and at most 5 success. Now, here this is a Bernoullis trial with n is equal to 6. And let us define P as the probability of getting an odd number as a success. Now here, therefore, the value of P is equal to 3 by 6, that's equal to 1 by 2. And Q is equal to 1 minus 1 by 2, that is also equal to 1 by 2. So, suppose if X will denote the number of success in the experiment, then X can have the values from 0, 1, 2, 3, 4, 5 and 6. Now, so therefore, using Bernoullis trial, we have probability of x is equal to x is NCX q to the power of n minus x into p to the power of x. So, p of x is equal to x is NCX into q to the power of n minus x into p to the power of x. Now, just substitute the values here. Now, this is equal to, what is n? N is equal to 6cx. What is q? Q is equal to 1 by 2 to the power of 6 minus x into p. P is also equal to 1 by 2 to the power of x. So, using law of indices, this can also be written as 6cx 1 by 2 to the power of 6 minus x plus x. Minus x plus x gets cancelled. 1 by 2 to the power of 6 we will have. So, 6cx into 1 by 2 to the power of 6. Let us come to the first condition. 5 success. Here 5 success. P of x is equal to 5. So, P of x is equal to 5. Since what we know, P of x is equal to x, what we got from the previous, P of x is equal to x is 6cx into 1 by 2 to the power of 6. Now, put x is equal to 5, then this is equal to 6c5 into 1 by 2 to the power of 6. Now, just find out the value of 6c5. 6 into 1 by, this is 6 into 1 by 2 to the power of 6. Let us simplify this. This is 6 into 1 over 2 to the power of 64. 2 into 2 into 2 into 2. 6 times is 64. So this can also be divided by 2. So 2 3s are 2 2s are 2 3s are 2 2s are. 3 by 32 is the probability. That's it. Okay. 5 success. P of x is equal to 5 is 3 by 32. Now let us come to the second condition. At least 5 success. At least 5 success means P of x is equal to 5 plus P of x is equal to 6. So at least 5 means x is equal to 5 and x is equal to 6. So what is the value of x we got from the previous? P of x is equal to 6 cx into 1 by 2 to the power of 6. Substitute here. So this is 6c5 1 by 2 to the power of 6 plus again 6c6 into 1 by 2 to the power of 6. So just find out the value of 6c5. This is 6 into 1 by 2 to the power of 6 plus 6c6 is 1 into 1 by 2 to the power of 6. So 1 by 2 power 6 you can take out 6 plus 1, that is 7 into 1 by 2 to the power of 6. So this is equal to 7 divided by 64. That's it. 7 divided by 64. P of x is equal to 5 and P of x is equal to 6. That is 6c5 1 by 2 to the power of 6 plus 6c6 1 by 2 to the power of 6. 6 for 6c5 is 6, 1 by 2 power 6. 6c6 is 1, 1 by 2 to the power of 6, 1 by 2 power 6 out. 6 plus 1, that's equal to 7 into 1 by 2 power 6 is 7 divided by 64. Let us come to this. At most 5 success means at most 5 success can also be written as 1 minus P of x is equal to 6. 1 minus P of x is equal to 6. So that is nothing but 1 minus P of x is equal to 6 means 1 by 2 to the power of 6. That's all. This is 1 minus 1 divided by 2 power 6 is 64. Take LCM. 64 is the LCM. 64 minus 1, that's equal to 63 divided by 64. That's it. Now let us come to the next problem. This is very important problem indeed. Now what is the problem given? 10 eggs. So 10 eggs are drawn successively with replacement. So 10 eggs are drawn successively with replacement from a lot containing 10% of the defective egg. So it contains 10% of defective eggs. Find the probability there is at least one defective egg. So what is the problem? 10 eggs are drawn. So we are going to draw 10 eggs successively with replacement from a lot containing 10% of the defective eggs. So in the lot there are 10% of the defective eggs, and find the probability that there is at least one defective egg. So there is at least one defective egg. For that we are going to find the probability of getting at least one defective egg. Now let x denote the number of defective eggs in the 10 eggs drawn. Suppose if x will denotes the number of defective eggs where we are going to draw 10 eggs. So that is x denotes the number of defective eggs in 10 eggs drawn. Since the drawing is done with replacement, the trial as the Bernoullis trial, clearly x has a binomial distribution with n is equal to 10 and p is equal to 10 divided by 100. So the trial is a Bernoullis trial. Since x has a binomial distribution with n is equal to 10 and p is equal to 10 by 100, that's equal to 1 divided by 10, 1 by 10. So therefore the value of q is equal to 1 minus p, that is 1 minus 1 by 10. Take LCM. 10 is the LCM. 10 minus 1, this is equal to 9 by 10. So q is equal to 9 by 10. Now probability of at least one defective egg, that is to be determined. Probability of at least one defective egg. Right. The probability of at least one defective egg is nothing but probability of x is greater than or equal to 1. Probability of x is greater than or equal to 1. So this can also be written as 1 minus probability of x is equal to 0. 1 minus probability of x is equal to 0. So this is equal to 1 minus probability of x is equal to 0 means 10 C naught into 9 by 10 to the power of 10. So this is nothing but 1 minus 10 C naught value is 1. So into 9 by 10 to the power of 10, this is 1 minus 9 to the power of 10 divided by 10 to the power of 10. That's it. This is the simplified answer. That's all regarding this problem. Let us come to the last problem in this session. A person buys a lottery ticket in 50 lotteries, in each of which his chances of winning the prize is 1 by 100. What is the probability that he will win a prize when? At least once, exactly once, at least twice. See, very important problem for 5 marks. A person buys a lottery ticket in each of which his chance of winning the prize is 1 by 100. What is the probability that he will win a prize at least once, exactly once, at least twice? Now, what is the condition given? Let us denote. Let x represent the number of prizes winning in 50 lotteries and the trials are Bernoullis. Hence, clearly, we have x is a binomial distribution with n is equal to 50 and p is equal to 1 by 100. So, this is a binomial distribution. X is clearly a binomial distribution with n is equal to 50 and p is equal to 1 by 100 and q is equal to 1 minus p, that is 1 by 100. That is nothing but 100 minus 1 is 99 by 100. Okay. Now, let us write down the condition. Probability of winning in lottery at least once, that is nothing but probability of x is greater than or equal to 1. Before that, let us write the P of x is equal to x. P of x is equal to x is NCx q to the power of n minus x into p to the power of x. So, what is n? We have n is equal to 50cx into q. What is q? Q is equal to 99 by 100. 99 by 100 to the power of n is 50 minus x into p. What is p? 1 by 100 to the power of x. At least once is probability of x is greater than or equal to 1. So, probability of x is greater than or equal to 1 can also be written as 1 minus probability of x is less than 1. 1 minus probability of x is less than 1. So, x is less than 1 means that is nothing but 1 minus probability of x is equal to 0. So, what is the probability? Yes, we have, that is probability of x is equal to x is 50cx 99 by 100 to the power of 50 minus x into 1 by 100 to the power of x. Now put x is equal to 0 here. Put x is equal to 0. What you will get? 1 minus 50 c naught into 99 by 100 to the power of 50 minus 0 into 1 by 100 to the power of 0. So this is 1 minus 50 c naught is 1 into 99 divided by 100 to the power of 50 minus 0 is 50 into 1 by 100 to the power of 0 is 1. So this is equal to 1 minus 99 by 100 to the power of 50 is the probability of getting the lottery at least once. Now let us come to the second condition. Probability of winning the lottery exactly once means probability of x is equal to 1. Okay. Now same, just put x is equal to 1, that's all. If you put x is equal to 1, what we will get? 50c1. So probability of x is equal to 1 is 50c1. 50c1, 99 by 100. 99 by 100 to the power of 50 minus 1 into 1 by 100 to the power of 1. So this is 50 c naught. So 50 c naught can be written as 50. This is 50 into 99 by 100 to the power of 49 into 1 by 100 to the power of 1 is 1 by 100. So this can be written as 50 by 100 into 99 by 100 to the power of 49. So simplify this. This can be written as, so 51s are 52s are 1 by 2 times 99 by 100 to the power of 49 is the probability of getting at least the lottery once. Now let us come to the third condition. Probability of winning the lottery at least twice. At least twice means probability of x is greater than or equal to 2. So probability of x is greater than or equal to 2 can also be written as 1 minus probability of x is less than 2. This is nothing but 1 minus, what is the meaning of probability of x is less than 2 means probability of x is equal to less than 2 means x is equal to 0 plus probability of x is equal to 1. So probability of x is less than 2. That means here the probability of winning the lottery at least twice is probability of x is greater than or equal to 2. Probability of x is greater than or equal to 2 means 1 minus probability of x is less than 2. 1 minus probability of x is less than 2 means when x is equal to 0 or x is equal to 1. So what is this equal to? 1 minus probability of x is equal to 0. What is the general equation we obtained here? 50c. This is 50cx 99 by 100 to the power of 50 minus x into 1 by 100 to the power of x. Now put x is equal to 0 here. So this is 1 minus probability of x is equal to 0, 50c naught 99 by 100 to the power of 50 minus 0 is 50 into 1 by 100 to the power of x is 0 plus when x is equal to 1 means 50c1 99 by 100 to the power of 50 minus 1 is 49 into 1 by 100 to the power of 1, that is 1 by 100. Let us simplify this. After simplification, we are going to get it as 1 minus 149 divided by 100 into the quantity will remain the same, 99 by 100 to the power of 49. This is the simplified answer. That's it. 1 minus 149 by 100 into 99 by 100 to the power of 49. You will get the simplified. So the probability of winning the lottery at least twice is 1 minus 149 by 100 into 99 by 100 to the power of 49 times. So this is how we are going to solve the problem. So in the examination, they may ask any one condition. They won't ask all the three conditions. At least once, exactly once, at least twice. So like that they will ask. So that's all regarding the problems on binomial distribution and Bernoullis trial. So that's regarding this session. Let us meet with a different concept in the next class. Thank you very much. These type of problems are very important. You just practice and definitely it will be more benefit for you so that you can score good marks. So that's all regarding today's session. Thank you very much.